Got to be aware of the inbounder here if you're Philly.
It's off to Leonard, defended by Simmons. Is this the dagger?
Since the first televised game in 1940, the game of basketball has captured the hearts of millions around the world, providing nail-biting buzzer beaters and iconic sports legends. Like most sports, the main objective in basketball is to outscore the opposing team, and the most traditional yet exciting way to do so is to shoot the basketball from distance. This can take the form of a single-point free throw, a mid-range two-pointer, or a long-range three-pointer. To provide these winning points your team needs, the only way to sharpen your skills is through practice. At any level, shot training is a quintessential part of a basketball player's training regimen. NBA players will train their shooting skills for up to an hour and a half every day, equaling up to 500 shots, with training staff ready to pass the ball and return it to their location. But what if you're like me? What if you're not LeBron James, Kevin Durant, or Steph Curry? What if you don't possess the state-of-the-art facility or the staff? Achieving the most optimized practice session may be quite difficult. For someone like me, a shot attempt means fetching the basketball. Enter the Swish Trainer, developed by Swish, where sports performance and skill training meets engineering and ingenuity. But first and foremost, allow us to introduce ourselves.
Hi, my name is Ray. I am the CCO of Swish. I am a systems engineer, and my roles at the company are prototyping, mechanical testing, and 3D modeling of the Swish Trainer.
Hi, my name is Jordan. I'm the CEO of Swish. I'm in computer engineering, and I'm in charge of the system integration and embedded software.
I'm Tim Tran, and I am the CFO of Swish, and I am in computer engineering, and I worked on the rotation mechanism integrated with OpenCV.
My name is Devan Chopra. I'm a fifth-year computer engineering student. I'm the CIO of Swish. I'm mainly working on the software side of the project, in particular the motion tracking and color masking strategies.
Hi, I'm Mary Polovina. I am the CTO of Swish and in computer engineering, and I help out with mechanical design, assembly, as well as software integration.
The Swish Trainer is comprised of two main components: ball launching and player tracking. The purpose of ball launching is to replicate the scenario where the basketball is passed back to the player. To achieve this, two 24-volt DC motors are mounted to a frame to provide the necessary and efficient trajectory. Most basketball passing systems currently on the market have a fixed location to where the basketball is passed to. If you want to change from where you're shooting from and where the ball is passed to, this means stopping your system, adjusting it, and restarting your practice from that new position. This is where player tracking comes in. Swish is utilizing computer vision algorithms to continuously track where the player is on the court. That way they don't have to pause their practice if they want to shoot from a different location, allowing dynamic position changing. The player tracking system is intuitive, thanks to the use of open computer vision and a Raspberry Pi. The behavior is to keep the player in center frame at all times. This is achieved by a camera mounted onto the rotating platform. The player is detected in real time throughout their practice session. When OpenCV detects that the player stepped out of the center frame, it determines whether the player has moved left or right. OpenCV will then send the appropriate pulse width modulated signals through the Raspberry Pi to the servo motor. The two 24-volt DC motors are mounted in a vertical orientation by a wooden frame. This allows two large rubber wheels to make contact at the top and the bottom of the basketball. With the results speaking for themselves, the vertical frame orientation allows for excellent passes at free throw range and beyond. Wired and mapped to a motor controller shield and an Arduino Uno, the two motors' voltage control is intuitive and paves the way for further development in range detecting safety designs of our launch system. Stationed at a slight angle and with the freedom to rotate, the launching system is designed to provide efficient passes to players at multiple positions and distances. The main question is why? Why do we need all this? By analyzing our free throw test footage, it took an average of 13 seconds to get a shot off. fetch the ball, and return back to the free throw line to continue. Meaning if I practiced for 1 hour, I would get 282 shot attempts. With the Swish trainer, it took 10 seconds for the ball to be back in my hands once I simulated a shot. No fetching required. Meaning that if I practiced for 1 hour with the Swish trainer, I would get 360 shot attempts. So, suppose I practiced every day for 1 hour, 7 days a week, for 4 weeks. Without the Swish trainer, I would have attempted 7,896 practice shots. And with the Swish trainer, 10,080. This fluid training session our system provides simulates the dynamic aspects that players can expect in live games, where making shots from a multitude of locations can mean the difference between winning and losing.